morning, students. In continuation of our teaching on radioactivity, today we want to look at mass defect and binding energy of a nucleus. Our objectives will be atomic mass units of protons and neutrons, nucleon number, which we call mass number in chemistry, mass defect, and then binding energy. We'll start with the atomic mass unit. Okay. Proton has its own mass, so also neutron has its own mass. We calculate it in terms of, not in terms of kilogram, but in terms of atomic mass units. I want you to see the values here. It is 1.00728 for proton, 1.00867 for neutron. There's a reason for these values. Please take note of these values. Let them stay in your mind. Now, nucleon number. Nucleon number. You are told in chemistry that our atom consists of a central nucleus. This nucleus is made up of protons and neutrons. And then we have electrons going around the nucleus of the atom. When we say nucleon numbers, we mean the sum of the protons and the neutrons of that atom. They form what we call the nucleon numbers. If we have 5 protons and then we have 5 neutrons, it means the nucleon number will be what? 10. Our nucleon number will be 10. In chemistry, it is called mass number. I use the word mass number because there are times they may interchange this value, these words. Now, mass defect. Mass, if I say this is the difference between the sum of the individual protons and neutrons and the mass number, or you say and the nucleon number. Nucleon number. And the nucleon number. What I mean is this. Now, I showed you the mass of a proton. I said the mass of a proton is 1.00728. I said that's the mass of a proton. And then the mass of a neutron is 1.00867. When we say mass defect has to do with loss in mass. Loss in mass. We discovered that if we have protons, neutrons, let us say we have 5 protons or 5 neutrons. Now, when they come together and form a single mass, which we call neutron, which we call nucleus, we discover that there will be a reduction in mass. Instead of the actual mass, we'll be having a reduction in mass. I gave an example here. Look at helium. Helium has a mass number of 4. Okay? It has 2 protons and 2 neutrons. The mass of helium is 4. But let's carefully look at it. If 2 protons will give us 2.01456. Now, and 2 neutrons will give us 2.01734. That is, 2 protons is 2.01456, and then 2 neutrons 2.01734. If we add them together, the mass is going to be 4.0319. But we discover that it is not so. The mass of helium is actually 4 and not 4.0319. So the difference in mass is what we call the mass defect. Difference in mass between the sum of the individual protons and neutrons and the mass, the actual mass of the atom. We call it what? Mass defect. Binding energy. Binding energy will help us explain mass defects in a way. We say binding energy is the energy released when the particles of the nucleus, the particles are the protons and the neutrons, okay, when they are fused together, when we bring the protons and the neutrons and bring them together, okay, the energy released in the process, we call it what? We call it binding energy. It can also be defined as the energy absorbed, okay, when we split the protons and the neutrons that make up the nucleus of an atom. This energy came because of that mass that was lost. Okay, we call it the mass that was given off, what that we call mass defect. It goes off in form of energy, in forms of heat energy. And Albert Einstein helped us with this equation that relates the energy and the mass. He said E is equals to mc squared, where E is the energy release, M is the mass defect, and then C, the speed of light. Okay? In the next class, by God's grace, we'll be looking deep into the calculations of these things. Thank you very much. See you in Google class.